Hello and welcome to this tutorial dealing with power calculations. We're going to do a couple examples together, and you can always pause and go back and that sort of thing to make sure you understand. So let's do some examples. We're going to do a couple examples. You get these formulas on the test. Okay, there are 3 of them. And something that might be worthwhile to do right away when you get the test is to put the units in that you're measuring these. So for example, energy is measured in joules, power is measured in watts, time is measured in seconds. So putting those values in the formula triangles, putting that in right away when you get the test, I think is helpful. Okay, so here is the first question. A 10 amp appliance has 120 volts across it. What is its power rating? That is a great question. So your first step has to be, what is this question asking? And it is asking for power. Okay, and so I know these look like a jumble right now, but we've got power here, P. And we've got power here, P. So both of these triangles can solve for power. This one does not have power in it. So we're going to have to use one of these. Okay, what else do we know? Well, it is a 10 amp appliance. Amps is current. It has 120 volts across it. That is voltage. So we're looking for power. We've got voltage and current. We can use that triangle. Okay, and so we will use that formula. P equals V times I. And we're going to put those values in. So the voltage is 120 volts. The current is 10 amps. Boom. Okay, and now we can solve. 120 times 10, that is 1,200. And what is power measured in? Right, we are solving for power. Power is measured in watts. So there is our final answer. And a question like that on the test is worth 3 marks. Okay? So if it says on the test, has a question and it says in brackets 3 marks, that means there's 3 steps like that. Okay? Next. How long would a load have to be on if it has a potential difference of 90 volts across it and 15 amps through it, and if it consumes 10,000 joules of energy? Whoa, that is a lot of words. Okay, but again, step number 1, what is this question asking for? And if we look up here, how long would a load have to be on? That is most certainly time. We are looking for time. Okay? And only one of these has time. That is right here. T. Okay, so we are looking for time, so we need to use this triangle. T equals E over P. There's our first step. Okay? That's how we use these triangles. It's looking for time. Time is equal to energy over power. Okay? All right. Do we have energy? Energy is measured in joules. And what do you know? We do. Do we have power? Power is measured in watts. And we do not know the number of watts. So now, if we did have the number of watts, we could just go 10,000 joules divided by whatever it is, 1,000 watts. Okay, we don't have the number of watts, so we have to find the power rating of this load. So we've tried this triangle. We came up with this formula. We need to use a new formula to find power. So we're going to go over to this one, right there, and go power is equal to voltage times current. Because that'll give us power, and we can insert that into here. Okay? Power equals voltage times current. Okay, and for this formula to work, we need the volts and the current. So voltage is measured in volts, current is measured in amps. We have the volts and we have the amps. 90 volts times 15 amps is roughly 1,350 watts. Okay, power is measured in watts. Okay, now why did we do that? Because the question is asking how long would a load have to be on? That's time. So we're going to go energy divided by power. Here's the energy, 10,000 joules. And now we've got power. We can calculate. 10,000 joules, that's a lot of joules. Divided by 1,350 watts. And that is 7.41 seconds. Okay, so that's how long it would have to be on to consume 10,000 joules of energy. Okay, so a question like that, we used two different triangles. That's going to be worth 5 marks. So on the test, when you see a question, it says in brackets, 5 marks. That's a clue. You got to do something like this, where you start with one triangle, this one, and we are missing one bit of information, so you're going to have to use a second triangle. Okay, that's what we did here. We found power. There's 1,350 watts, and then we inserted it into this triangle, into this formula. 10,000 joules divided by 1,350 watts. And that gave us time. Okay, next question. 7,488 joules of energy are consumed in 9.6 minutes by a bulb, a light bulb, that has 120 volts across it. What is the current running through it? Step 1, what's the question asking for? It is saying, what is the current running through it? Current, as we all know, somehow got stuck with the letter I. Okay, so current is I. Now there's this formula, I equals P over V. There's also this one, I equals V over R. Okay, so let's see what one would make more sense. So if we're going to use this triangle, we need the watts and the volts. Okay, do we have the watts or the volts? We have the volts. We do not have the watts. If we're going to use this triangle, I equals voltage over resistance. So volts and ohms. Again, we have the volts. We do not have the number of ohms. We don't have the resistance. Okay? So if we're going to use this one, we're going to have to find power, right? The number of watts. If we're going to use this triangle, we're going to need to find the number of ohms. Now we don't have another triangle that will give us ohms. We do have another triangle that can give us power. That's this one. Okay, so that's a little clue that we're going to use this triangle to start. It's asking for the current. Here is the current. I equals P over V, the watts divided by the volts. And again, we have the volts. Okay, we do not have the number of watts, but we have another formula. Energy divided by time, that will give us the watts. Okay, so power equals energy over time. Energy is measured in joules. Time is measured in seconds. Wait a minute, hang on. We've got the number of joules, but we don't have the number of seconds. We've got 9.6 minutes. What is this teacher trying to do to us? Well, we can convert minutes to seconds. So I'm going to do that kind of off to the side here. Okay, 9.6 minutes. I'm going to do a factor conversion. Okay, minutes to seconds. So I've got minutes up here. I want to get rid of minutes, so I'm going to put minutes on the bottom and seconds on top. Okay, and now I have to put numbers in. So if I've got minutes on the top and the bottom, they will cancel out and I will be left with seconds. Okay, now what numbers do I put in here? I like to give the bigger unit a 1, and minutes are bigger. And then how many seconds are in a minute? There's 60 of them. Okay, now how do I calculate this? I go 9.6 times 60 divided by 1, and that gives me 576 seconds. Okay, Now, what do I do with that? I want to put that as the time in there. So 576 seconds. What a beast of a question. But when you solve these, you feel really good. Okay, so power is joules over time. Okay, that gives us 13 watts. Now, why did we figure that out? Well, think back. The question was asking, what is the current? The current is power over volts. We had the volts, 120 volts. Now we've got power as well. Okay, so I'm going to fill that in over here. 13 watts, right? That's what we just figured out, divided by 120 volts. And that gives 0.1083 amps. Okay, now a question like that, most of the questions on the test are not going to be that long. Okay, that's a big, tough question. The key is figure out what's the question asking for. It's asking for current. What's the formula? This time it was a bit tricky to figure out, okay, do I use this triangle here or do I use this triangle here? But you know what? If you tried this triangle, you'd find the volts and then you'd be like, I can't find resistance. Let me try the other one. Okay, so don't give up. Just keep trying and you will probably get there. Okay, so I'm hoping that that was helpful and that that kind of makes sense. You can always contact me, rewatch videos, and don't give up. Find your formula, start there and start plugging things in, and you will usually get there. Okay, I'm rooting for you. You guys are going to do great. Take care.